Let's go over question number 15. And for you to understand the solution to this question, we need to first go over the summary of the SN1 reaction versus the SN2 reaction for haloalkanes. This is found on table 9.9. For primary haloalkanes, the same goes for methyl haloalkanes. The SN2 is the one that will take place. And why is this? Well, SN1 does not happen really for primary haloalkanes because that will require the formation of a primary carbocation, and they are not stable. If we have the secondary haloalkane, you can either get the SN1 or the SN2, and this just depends on what type of nucleophile you are going to use and also the type of solvent that you will use. For SN2, you want to have an aprotic solvent with good nucleophiles. For SN1, they work best in protic solvents and using poor nucleophiles. And keep in mind that for SN1 reactions, you have the possibility of carbocation rearrangement. Because every time that you form a carbocation in the reaction mechanism, there is the possibility of rearrangement. So do not forget that. When you have a tertiary haloalkane, then you do not have SN2, but you do have SN1. And it's best when you have a tertiary haloalkane because they will form tertiary carbocations, and those are the most stable. The more stable the carbocation, the faster the reaction. And let's keep in mind the stereochemistry of the reaction. You will get the inversion of configuration for SN2 reactions, and this happens because the nucleophile attacks the chiral center from the opposite side of the leaving group. And let's take a look at SN1. When you have the SN1 reaction, you can do a prediction that you will get a racemic mixture because the carbocation intermediate that you form in the rate determining step of the reaction mechanism, that intermediate, that carbocation is planar. That means the nucleophile could attack this intermediate from either side. And that's why we can do the prediction that we will synthesize a racemic mixture whenever forming a chiral center. All right, let's go over the first reaction of problem 15. You need to complete this reaction and also identify the reaction as SN1 or SN2. Just as we saw on that table, table 9.9, we need to first identify what type of haloalkane we have. And this one is a secondary haloalkane. And when we have a secondary haloalkane, it could either go SN1 or SN2. So you have to keep looking. Let's take a look at the type of nucleophile that you have. But here you have water and you have methanol. They can both be acting as nucleophiles. In this case, they are also a solvent. So you have water and you have methanol. They are both poor nucleophiles and they are both polar protic solvents. So we can say because of these poor nucleophiles and polar protic solvents that we will have the SN1 reaction. Okay, so it's a nucleophilic substitution reaction. So what you want to do is to replace the leaving group. The Cl is your leaving group with the nucleophile. In the case of the alcohol, when using the alcohol as the nucleophile, you will put just the OCH3 without this hydrogen. When you go over the reaction mechanism, you will see why that hydrogen is not included. And when we have the SN1, what is the stereochemistry of the reaction product? But for the SN1, we have one chiral center And we will have a racemic mixture. And we have another product. What about when we use water? When we use water as a nucleophile, we will have just the OH group. Now you are forming an alcohol. And this is a chiral center, so we can say, okay, we are forming the racemic mixture here as well.